Hello everyone. So now let us see some kinds of sets. Okay. So first one, let us say what is called empty set. What is called empty set? A set which has nothing is called an empty set. Say let A be an empty set, then we denote it by this symbol, which means it is a set. Inside set there is nothing, right? So this is called an empty set. The another way of writing this empty set is this is the notation of an empty set. Okay. See, some students have misunderstanding, like if you ask them to write the empty set, they will put 0 like this. No, 0 means it's an element. Set is a collection of element. It is a collection of an element. This is some element. Don't think that 0 has no value. No, that is a numerical. Set means it's a collection of objects. That's all. Okay. So we should not write this. So this is called an empty set. If you put 0, that is wrong. The another equivalent words for empty set is we may say empty set or null set or void set, all are same. Okay, fine. So the next one is what is called singleton set. What is called singleton set? Singleton set means nothing. A set which has only one element, that is called singleton set. Okay, it could be in any element. Say let us say some A. Okay, so a set which has a single element, that is called an singleton set. See, note another thing. We always write an elements of a set only in a small letters, right? But we denote the set in a capital letters. Okay, we have to denote the set in a capital letters, and we have to denote the elements inside the set is in a small letters. Okay, fine. So the third definition is what is called finite set. A set which has a finite number of elements, that is called a finite set. See, just ignore what are the elements inside the set. They could be any kind of element, right? Say A has elements 1, 2, 3, 4 like this. This is a kind of usual set we see in books and all. Maybe it need not to be always look like this. Say B be a set. It has some objects like this or this something or this something. Yeah, fine. There are some 3 objects. That's all. So object could be in any manner, right? But the only thing, if we count them, we should end up with a finite number. This is 1, 2, 3. So totally we have 3 numbers. Okay. And another important point of 2 points of a set is, one thing is inside the set we don't have a order, which means this set A can be written in this form also, say 2, 3, 4, 1, right? Or it can be written in 3, 4, 2, 1 like this. There is no order, but this is also A, this is also A, right? So there is no order inside the set. And the second thing is, there should not be a repetition inside the set. For example, we should not write a number 1 twice inside the set. This is wrong. So there should not be a repetition inside the set, and there is no order inside the set. Okay, fine. Okay, the next one is what is called infinite set. A set which has infinitely many numbers, that is called infinite set, right? Give an example of infinite set. Say set of all natural numbers, set of all whole numbers, set of all integers. Say all kind of, maybe set of all stars. Fine. You just list all the stars of this universe. How many are they? You don't know. It's just going on. So yeah, it is an example of infinite set. Fine. Okay. So what is called the next one is called equivalent sets. So equivalent sets means, yes, of course we have to take 2 sets. Say let A be one set and B be another set. Say A has some elements. A has some elements, say 1, 2, 3 something, and B has some elements. A, B, some X something. Yeah, fine. So now when we can say A and B are equivalent sets, when A and B have same number of elements, then we can say A and B are equivalent sets. So same number of elements means say cardinality of A means the number of elements of A. Fine. So the number of elements of A is 3. The number of elements of B is, that is cardinality of B is 3. Yeah. cardinality of A and cardinality of B is equal. So we can say A and B are equivalent set. Simply, if two sets are having the same number of elements, then we can say they are equivalent sets. Fine. Here we have to make we have to make a note of one thing. See, students used to read it as a mod A and all. No, this is called cardinality of A. We use this notation in a different places, like in determinants, as a mod. Fine. See, inside the symbol, if you write a set, here A is a set, then we have to read it as a cardinality. Okay. Inside the symbol, if you write some real number, then we have to read it as a modulus. Inside this set, if you write some matrix, if this is a matrix, then this notation is meant for a determinant. Fine. Don't get confused with these notations. Fine. So the next thing is what is called equal sets. Yeah. See, take the previous example itself. Students usually confuses with what is called equivalent sets and equal sets. Equivalent sets means two sets are said to be equivalent when they have same number of elements. Two sets are said to be equal when they have same number of elements, but that is not enough. The elements also should be same. In the sense, A is equivalent to B, but A is not equal to B. Equivalent, equal. Make a distinction. If we have B as, say, let me take it as C to avoid the confusion. Here A and C have same number of elements and also have same elements. So here we can say A and C are equal sets. Equal sets are of course equivalent sets, but equivalent sets are need not to be a equal set. Fine. Try for many examples, send to us. Thank you.